So we are into the same topic still, first order, first degree ODE, and format this time will change. So this is lecture 6 for ODE. Let's understand the format now. For example, coefficient of dx will be the function of x and y. Coefficient of dy will be the function of x and y. So you have to check what is the degree of this coefficient. So you can see here power is 2, so degree is 2. This side also power is 1, 1, so total degree is 2. So degree is 2 for both the coefficients. Now is equal to 0 is there, notice. So we will consider this x square minus y square, which is here, as a function m, and that will be the function of x and y. In same way, 2xy will consider as n. That will be another function psi xy, means phi xy and psi xy. Okay. So actually the given function, the given format what we are going to discuss in this lecture, that will be like m dx and n dy is equal to 0. When this kind of format will come in GATE exam, there is very best way. You have to check the degree and take the x power that much common. I will show you how. And then that's all, substitute y is equal to vx, almost done. So this format we need to learn today. So how this format is different, please check previous examples. For example, you can see if this is given like dy by dx is equal to sin x plus y cos x plus y, like this. So this kind of format you cannot write in m dx plus n dy form. Okay, what I'm learning today. So even if we write that or you try to write that format in m dx plus n dy, it is not being possible. So m dx plus n dy is equal to 0 type is a special format known as homogeneous differential equation. It means we are learning first order, first degree homogeneous differential equation, right? Because in GATE syllabus what is mentioned? First degree, first order. So in first degree, first order, one format is homogeneous. So let's understand the steps. So when you have m dx and n dy, you rearrange such that dy by dx we can find out. Okay, we got dy by dx. Now in that minus m by n will come. Now send the minus sign inside, so it will become m by n something like this. For example, if m is x square minus y square, then send minus inside, it will become y square minus x square, like that. So we got two functions here. Now your job is, because I know the degree already in the question itself, as you saw, phi and psi has some order, same order 2. In this example, order was 2. So in above example, so consider 2 as n, because in general way, for general discussion of other questions. So you have m, that was phi x, for that also degree was n. You had n psi x, for that also you had same degree n. So now dy by dx, what you are writing, in that you take x power n common from phi also and x power n from psi also. How will you decide n? N is degree. In the question itself it will be visible. Degree, don't be confused. I am not talking degree of differential equation, degree of the coefficient. So actually question was x square minus y square dx, 2xy dy. Now what I am saying, write down as dy by dx. So that is x square minus, I am changing the color. Okay, so this you can see here, I have written here minus x square minus y square by 2xy. Now send that minus sign inside, it will become y square minus x square by 2xy. After that, what is the degree? Degree is 2 here. So x square means x power 2 you take common. So from the top also you take x square common, which is here, and from the bottom also you take x square common. Now see, in some question it can be x power 3, in some question it can be x, in some question it can be x power 4. So degree you decide in the beginning itself when equation is written in m dx plus n dy form. That time itself you decide degree. So it will be in your mind that okay, x power something you have to take common when after writing dy by dx form. Now it's like here also you have y by x square, here also you have y by x square. It means function became the function of y by x throughout. So now dy by dx is actually behaving like a function y by x. That is fine. Now take y by x is equal to v. So as usual, if y by x is equal to v, then y is equal to vx, then dy by dx is equal to v plus x dy by dx. Means we are substituting y is equal to vx value here. So dy by dx will be v plus x dy by dx. So from the taken example, here it was like x square by x square was there, that you can cancel, right? And yx whole square you can replace as v square minus 1, and here bottom you had 2 y by x, so it will become v. Okay, now take this v right side and take LCM. So this step will come, and then v square minus 2v square will become minus v square, and this minus 1 will be remaining as minus 1 by 2v as it is. Okay, now you can separate the variable in x and v. So separate the variable in x and v. So dx by x and 2v divided by minus 1 minus v square. Now see guys, there are two ways to solve this. If you are very good, if you have very good practice in integration, then you can easily see here that it is a format of f dash x and fx. So ln fx will be your answer. But if you are not very good practiced in integration, then the bottom part you consider as t, differentiate one time, minus 2v dv is equal to dt, then say minus on that side, minus dt will come, substitute the values here, minus here, dt by t here, and that's all. Then ln t and ln x, ln c. Now I told you in last classes also, when you have ln coming in the solution, then constant also you should write it in form of ln. It is general practice. So I got it. So this is the answer, and then I'm just rearranging forms, and after rearrangement I got this as final answer. That's all. Now go for second equation. Second question, same thing again, x minus y whole square dx is given, 2xy dy. This question is slightly different from the previous equation. So here also you can see power is 2, so degree is 2 for this coefficient, and here 1 so degree is 2 for this coefficient. I am not talking about 2-degree differential equation. I am talking degree of the coefficient, which is the function of x and y, that has degree 2. So first thing, you rearrange dy by dx. I rearrange dy by dx. Then you know degree is 2. So from the top also you take x square common, from the bottom also you take x square common. So after rearranging like this, I am taking x square common here and x square common here. So here I got y by x, and here I got xy by x square. So if you solve, you'll be having 1 minus y by x, and here you have y by x, and here you got like this, again function of y by x. So again same thing, y by x replaces y, and y is equal to v into x. So dy by dx is equal to v plus x dy by dx. These three things you have to substitute in the equation. So substitute in the equation, this is dy by dx, and this is v. Now this v you send right side and take LCM. So this step will come, then cut few things and cancel few things, so this step will come. Now see here, it is challenging question. You can see this is quadratic equation, this is 2v. So separate the variable first. So I have taken v one side and x one side, variable separated. Okay, now see this 3v square minus 2v plus 1 is there. How will you solve this? So see, first of all you should think in this way. If I will differentiate 3v square minus 2v plus 1, what will come? If you differentiate, 6v minus 2 will come. But at the top, we don't have 6v minus 2. It means this is not the format of f dash x by fx. So what will you do? So you will try to convert this as a format so that it will look like f dash x by fx. It means what? Somehow you try to bring here 6x minus 2 at the top, so that if I will differentiate the bottom, the top will come. So because you need some extra numbers at the top, so some extra numbers like 6 and 2. So to cancel out 6 and 2, you have to balance also by some extra numbers. Okay, it means what? Your integration is going to split in 2 parts or maybe in 3 parts. Okay, so you know one trick. Whenever you have ax square plus bx plus c, directly remember this formula to split the quadratic equation into perfect square. So you can see here, this guy became perfect square. What is the formula? You have 2 terms in that. In first term, a is outside. In first term, a is outside. Bracket x plus b by 2a whole square. And then second term, c minus b square by 4a, only 4a, not 4a square. So b by 2a is here. B square by 4a is here. Here also you have a. Here also you have a. Here also you have a. Okay, fine. Now see, by using this concept, you can convert any quadratic equation into perfect square. Some students are having trouble converting quadratic equation into perfect square. But why do we do this? Because it helps us to do integration. For gate point of view, it is very, very important. For example, we have 3v square minus 2v plus 1, right? Now this part, what is my a value? 3. What is my b value? Minus 2. What is my c value? Plus 1. Okay. Now this a, b, c, if I substitute in the above equation, then it will take this format. 3 bracket v minus 1 by 3 whole square plus 2 by 3. Okay, fine. Again focus here left side. Why did I teach this part? Because we have to use this in upcoming steps. Now bother about the left side part. So this 2v, first of all I want to convert this into 6v minus 2 format. So for that what will I do? I told you that if this I will differentiate, 6v minus 2 will come. That's why I want that at the top. But how? So this 2v is there, right? Okay, in that you add here minus 2 and subtract and add plus 2 plus 2. After that you do one thing. Overall I see different students can have different way to settle down these numbers. Depends how practiced you are. Simple. So multiply 3 and divide by 3. So this multiplication 3 you send inside, so it will become 6v, and then you send for this it will become minus 12, and then send here it will become plus 12. But I don't want, okay, this 1 by 3 will not create trouble because that is a final constant. I can keep that outside. Now this 12, what you are seeing here, minus 12, that minus 12 I can split as minus 2 and minus 10. Then this minus 10 and plus 12 I will take as plus 2. It means inside I have got 6v minus 2 and plus 2 separately. So 6v minus 2 I got in one side, and this extra 2 I wrote here, and by 3 I took both with both. Okay, fine. Now this part is clearly visible that this guy is your fx and this guy is your f dash x. So ln fx will be your answer. So ln fx is my answer now. This 1 by 3 as it is, and here this is my fx. So this part is done. Now only substitute v is equal to y by x. That's all, this part done. Now you bother about the second part. In second part, see, whenever you have constant by quadratic equation, that quadratic equation you always convert into perfect square and then apply that formula. So whenever you convert any quadratic equation, it will take this form, either x square plus a square or x square minus a square or a square minus a square form it will take in integration. I told you that go and solve your complete integration from NCERT, then you will be very good in integration. Okay, so 1 by a tan inverse x by a for the first one, and if you have minus a square, then 1 by 2a ln x minus a divided by x plus a. If you have a square minus x square, then 1 by 2a ln a plus x, a minus x. So these three formats will come always. Okay, and one more thing can be there that I will take in next example. Even a root can be there. If root will be there, then how the formulas will change, I have taken in next example. So anyway, right now you don't have root, so don't be confused. So you can see which one is suitable for us. So you can see this guy looks like, okay, first of all remove 3 from here because I don't have any coefficient here for the x. I don't have any coefficient for the x, right? So remove 3 from there, means remove this 3. So then it will look like I took this 3 outside, so I'm getting 2 by 3 was already there. I took 1 by 3 also outside. So now here it will become 3 into 3, so it will become 9. So this 2 by 9 I can write as root 2 by root 3, root 2 by 3 whole square. So now this guy is behaving like a square, but here one extra number came. I mean, we know the formula for x square plus a square, but what if this x becomes x plus or minus b square plus a square inside? Don't worry, this will not affect your final answer. Only in the final answer where you are getting x, there you will be getting x plus minus b. It means I'm having this as v minus 1 by 3. So in the final answer here, v minus 1 by 3 will come. Remaining other places 1 by 3 will not come. After that, you can see 1 by a will come. It means that a square from there, a will come. So that is nothing but this is 1 by a, and tan inverse, this is complete x, means v minus 1 by 3, and this is 1 by a again, right? Done. After that, just replace your y by x. V is equal to x, final answer. So we got two terms here. One term I solved separately and last term I solved separately. So now add both in the final answer. Now I'm giving you x square y minus 2xy square dx, x cube minus 3y square. Now whenever you have these kind of questions, it looks flat, dx separately, dy separately, always think that there is chance that it will be homogeneous equation. So when you see that, you bring both the terms try to arrange like dy by dx. But remember, check the degree of the coefficients. So here power 2 power 1, so degree is 3. Here power 1 and 2, so degree is 3. Here directly degree is 3, and here 1 and 2 and 1, so degree is again 3. Now you go, because you know now degree is 3, so you do like a homogeneous part. So from the, okay, now arrange dy by dx. I got like this. Now take x power 3 common. This is the trick in homogeneous cases. What is the degree? Take common. So x power 3 common, x power 3 common. So it will take like this kind of format. Again it became y by x function. Okay. Now simple thing, you replace y by x as v. So wherever you have y by x, v will come, and dy by dx will be equal to v plus x dv by dx. So that's all. Put the values and then send this v right side and take LCM, and then this kind of format will come, and this was the easiest one. Then split this for this and for this. 1 by v square minus 3v by v square, it will get cancelled out. That's simple. Now this will become minus 1 by v, and this will become minus 3 ln v. That's all done. And here ln x plus constant ln c, and v value you replace. Now this is very interesting question, because here I have given dx at 2 places. So if suddenly this question will arrive in GATE exam, then many students may think that dx 2 places. Now what to do? Very simple. Bring dx together. So here this y dx and this dx. So y dx I have got this side, so dx together. Now take this dx common, so it will become single term. Okay, and send dx down. So I got dy by dx, and send this x here. Now I know what is the order, what is the degree of the coefficient in this. Power 1, here also power 2, but because of root power 1. So only x I will take common this time. So I took x common. So y by x, and then 1 plus y square by x square. Now I got properly, x will get cancelled. I got properly as a function of y by x. Fine. So here, this part is your dy by dx part. And now this v plus this part, which is remaining here, v plus 1 plus v square under root. Fine. So now I told you, right, you can have quadratic also, square root also. So for square root you have 3 famous formulas. If you have under root x square plus a square, then and x square minus a square, it goes ln x plus whatever is the in the square root, same thing will appear here. X square plus a square, x square minus a square, right? But if you have a square minus a square, then sine inverse x by a will come. And make sure, if you have x square plus a square, then tan inverse x by a will come, but with 1 by a. But if you have this format, then 1 by a will not come in the formula. 1 by a comes in terms of tan. Okay, so there is a trick, tan, because a is present, that's why a will come. There is a trick in the formula. In sine a is not present, so a will not come. That's all. Then you can replace this for sine, and this one log. So now in next video we are going to see some equations which are reducible to homogeneous form, because we are going to cover entire, and this much practice is enough for homogeneous.